Day 309 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 164, maximum gap. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Question says, given an integer array nums, return the maximum difference between two successive elements in its sorted form. If the array contains less than two elements, return 0. You must write an algorithm that runs in linear time and uses linear extra space. So, y'all, that sounds simple enough, but let's go ahead and take a look at these examples so that we can make sure we are doing this question correctly. So in example 1, we have the input nums equals an array of integers 3, 6, 9, and 1. The output is 3. The output is 3. The explanation says the sorted form of the array is an array of integers 1, 3, 6, and 9, and either 3 and 6 and 6 and 9 has the maximum difference of 3. So as you can see in this sorted array, the maximum difference between all of these numbers that are next to each other, the maximum difference would be 3, right? So in this case, 3 and 6, 6 minus 3 has a difference of 3, and 6 and 9, 9 minus 6 has a difference of 3. Now you can see right here, 1 and 3, 3 minus 1 has a difference of 2, but that's not what we want. That would be the minimum difference. We want the maximum difference. And it's also important to remember, right, that we have to sort this original input array, because if we don't sort it, then the maximum difference would be different, right? This would be a difference of 8, and that's not the correct answer. So we have to remember to sort this first and then find the difference, because then this we move, by sorting it, we move this 1 to the front, boom, like we did here, and then that gives us a whole new difference. Now that difference is the last difference would be 2 as compared, excuse me, y'all, as compared to 8, right? So that's a big difference. That's a difference in the output, right? Because if 8 was the maximum difference, then the answer would be 8, but that's not correct, because really the 1 should be in the front and next in front of the 3, and the 1 should contribute to a difference of 2. So that's one thing that we have to remember. Make sure you sort the input array as well. I'll go into that further when we get into our solution as to how we're going to sort it. So now, before we get to the solution, y'all, let's get into example 2. So in example 2, we have the input nums, which is an array of integers. That only integer is 10. The output is 0. It says right here, if the array contains less than 2 elements, return 0. As you can see, this input array contains less than 2 elements. Explanation says it too. The array contains less than 2 elements, therefore we return 0. So now that we understand how the question works, let's get into the fun part, the actual solution, y'all. And for the solution, we are going to be using a bucket sort, right? Because we want to do this, and we want an algorithm that runs in linear time, and uses linear extra white space, or linear extra space. So since sorting directly, that would take a big O of n log n complexity, we're going to use the bucket sort, which is going to help us to achieve a big O of n complexity, which is what we want. So in order to do that, the first thing we're going to do, we're just going to say let n equal nums dot count, just like that. Boom. Then we need to get the minimum and maximum values in the array. So we could just say, come underneath that, we could say let mi for min, we're going to set that equal to nums dot min, put the parentheses at the end. Then we could say let ma for max, let equal nums dot max, and put the parentheses at the end, just like that. And then, y'all, we could put, we need to put exclamation points right here as well. Boom. Then, if all elements are the same, then the maximum gap is 0. So we could just say if ma equals mi, then we could open up the brackets and we could return ma minus mi, just like that. Boom. Now we need to calculate the bucket size, and to do that, this is the formula to help us create the bucket size. Just in case y'all don't know, I'm gonna just write it for y'all so y'all can see. It would be it'd be open up the parentheses. It'd be max. Y'all don't have to write this, so if you do, you could comment it out if you want to. So that's what I'll do. I'll just comment it out. But this is the formula that we use to compute the bucket size. So it's just then this would be n minus 1. So it'd be max minus min divided by n minus 1. Boom. And that's going to help us to find the minimum possible gap. Now, that's just how we compute the bucket size. Now let's actually create the bucket size. We're going to say let bucket size equal, it's going to be integer, open up the parentheses, we're going to say CEIL, open up the parentheses, it's going to be a double, then we're going to open up the parentheses again, we're going to say MA minus MI, come outside of these parentheses, we're going to say divided by, and that's going to be a double as well, open up the parentheses, it's going to be N minus 1, just like that. Now this right here, all this does, this seal, all this does is round up. That's going to round up our answer for us. Boom. And then the double is just going to allow us to use the decimals. So yeah, let's keep going. Now we need to create an array of tuples to store the minimum and maximum values in each bucket. So in order to do that, we could just say declare a variable. We'll call it min max bucket. Set that equal to an array. Open up the parentheses. Repeating. Open up the parentheses again. Min colon int dot max comma max colon int dot min. Come outside of that. Come outside of those parentheses, but still inside the other parentheses. We're gonna say comma count colon n. Boom. Now we need to place each number into a bucket and update the min and max of that bucket. So in order to do that, we can say, come underneath this, we can say for num and nums, open up the bracket. We could say let IDX equal, open up the parentheses, num minus MI. Come outside of those parentheses, and we're going to say slash, we're going to divide that by bucket size. And that's going to determine which bucket the number belongs to. Now we come underneath that, we're going to say min max bucket, boom, min max bucket, square bracket, IDX, come outside the square bracket, dot min, set that equal to min, open up the parentheses, min max bucket, square bracket, IDX, come outside the square bracket, dot min, comma, num, and this is going to update the bucket minimum. Now we need to do the same thing and update the bucket maximum. So in order to do that, we can say min max bucket square bracket IDX dot max. The dot max should be outside of the square bracket dot max. Set that equal to max. Open up the parentheses, min max bucket square bracket IDX. Come outside the square bracket dot max comma none. Boom. Now we need to initialize the maximum difference with the bucket size as a lower bound. So we could just call it come right here, we can call it declare variable, we call it max gap. That's colon, it's going to be integer. We're going to set that equal to bucket size. Boom. Then we're going to declare another variable called prev. Set that equal to min max bucket square bracket 0. Come outside of that dot max. Boom, just like that. And now it's time to iterate through the buckets to calculate the maximum difference. So to do that, we are going to use a for loop, and we are going to say for I in 1 dot dot less than n, or excuse me, 1 up to n less than sign dot dot less than sign n, where min max bucket square bracket I, excuse me, square bracket I dot min does not equal int dot max. So we're going to skip the empty buckets. We're going to open up the brackets. And we need to compute the difference between the non-empty buckets. So we're going to say max gap equals max, open up the parentheses, max gap, comma, min max bucket square bracket I dot min, excuse me, minus prev. Just like that. And now we need to update the previous bucket's max value. So in order to do that, we could just say prev equals min max bucket square bracket I, come outside the square bracket dot max, excuse me, dot max, like that. Then we just need to return the maximum difference found. So we come right here and we can say return max gap. Boom, just like that, y'all. So let's go ahead and give it a run. Give it a run. Let's see. It's taking a little while. It's taking a little while. That's never good. What is going on? Oh, we ran out of time. So what did we do? Where did we go wrong? That means somewhere. See, that means something is off somewhere in here. So let's see if we could find the needle in the haystack, y'all. Let's see, y'all. Let's see, where could we have went wrong? Sorry, y'all. Sorry, y'all. I don't know. Don't know. Might gotta, let's see. Let's just run it again, make sure it's not just my computer being slow. But I don't think it is. I think I messed up in the code. Oh, I see where I messed up at, y'all. Right. I see where I messed up. I'm going to let this finish. But I already know where I went wrong at. As you can see, this should be minus mi, not minus min. So now let's run it. See if that's what makes all the difference in the, okay, now we're getting somewhere. So cannot find, all right, so this should be IDX. Boom, now let's run it. Now let's run it. And it's accepted, y'all. Look at that. So now let's go ahead and submit it. Let's see, y'all. Hopefully it stays accepted after we submit it. And look at that, y'all. 11 milliseconds beats 78.26% of users with Swift. Not too bad. We have room for improvement. We'll make sure we get these numbers up as we continue down our LeetCode journey. But right now, we just want a solution that everybody should be able to understand and learn from. And I feel like this is a good solution for that. So with that being said, y'all, get one more look at the code. One more look at the code. Read it, learn it, love it. Boom. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.